As we transition from our previous discussion, let's delve into the current landscape of agentic AI security and governance. This topic is crucial for a wide range of professionals, including security operations, platform engineers, architects, product owners, and legal and compliance teams. Understanding the intricacies of agentic AI is essential, as it plays a pivotal role in shaping how we manage security protocols and governance frameworks in our organizations. In today's rapidly evolving tech environment, having solid grasp of these concepts is not just beneficial, it's imperative. With the rise of AI technologies, our responsibilities in ensuring secure and compliant implementations grow. As we move forward, we'll explore the learning objectives, equipping you with the knowledge to define agentic AI and comprehend its implications effectively. So let's get started. As we transition from our previous discussion on the state of agentic AI security and governance in the context of SecOps and platform engineering, let's delve into what you will take away from today's session. By the end, you'll be equipped to define agentic AI and recognize how it fundamentally shifts our understanding of security compared to traditional AI systems. You'll learn to identify various attack surfaces, prioritizing them based on their associated risks and business impacts. We'll also explore how to implement layered security approach, employing effective strategies to prevent, detect, and respond to potential threats. Finally, you'll gain practical experience in executing security testing, including running red team exercises and conducting thorough vendor assessments. With these objectives in mind, let's take our first step by understanding what agentic AI really is and how it differs from traditional AI systems. As we delve deeper into our learning objectives, let's explore the concept of agentic AI. Unlike traditional AI, which primarily focuses on generating text, agentic AI represents an evolution in technology. These advanced systems leverage large language models to not only generate responses but also to reason, retain context, and perform complex tasks autonomously. What sets agentic AI apart is its ability to maintain memory across interactions, allowing for a more personalized and coherent user experience. However, this capability comes with challenges. For instance, identical inputs can yield unpredictable outcomes, complicating reproducibility and forensic analysis. This unpredictability necessitates innovative security measures and monitoring strategies to ensure reliability and safety. Next, we'll transition into the realm of enterprise applications, examining how agentic AI can be categorized through an enterprise lens, particularly focusing on internal assistance with special access to relevant data. Let's continue our exploration. As we transition from our discussion on agentic AI, let's delve into the critical concept of agent taxonomy from an enterprise perspective. In the realm of enterprise agents, we have internal assistants equipped with privileged access to retrieval augmented generation systems, databases, and other corporate resources. This access generates a high level of trust, but it also introduces significant risk. And we have coding agents, which focus on automating code generation and integrating testing within continuous integration and deployment pipelines. Their direct access to source code and deployment environments makes their role pivotal yet sensitive. Client-facing agents, on the other hand, interact with customers through bots and public workflows, making them more exposed to external threats and potential adversarial inputs. Lastly, we have multi-agent ecosystems where agents can delegate tasks and engage in intricate interactions, leading to emergent behaviors. Now let's explore why it's crucial to regard these agents as approved insiders. Building on our discussion about enterprise agents and their privileged access, let's explore why it's crucial to treat these agents as approved insiders. These agents often operate under service accounts that come with broad role-based access control permissions. This means they can perform high-impact actions, such as sending emails, modifying records, or even calling payment abuse. However, this level of access also makes them targets for insider attack patterns, including data exfiltration, privilege escalation, and rat poisoning, all of which can occur through seemingly legitimate workflows. What makes these threats particularly insidious is that they can go unnoticed unless we have the right monitoring in place. To enhance your security posture, consider mapping each agent in your inventory to an insider profile. This approach helps you better understand your risk exposure and take proactive measures. Next, we'll delve into the protocols that can help create new framework for managing these agents effectively. Building on the importance of treating agents as approved insiders, let's delve into the protocols that define the new network for these agents. The agent tool protocols, including MCP and similar standards, play a crucial role in streamlining tool invocation, making integration simpler than ever. However, this ease of access comes with trade-off: an expanded attack surface for tool invocation. To facilitate secure interactions, the agent protocols, namely OWASP and ACT, support cross-vendor delegation while emphasizing the need for cryptographic identity, robust trust frameworks, and discovery security. Speaking of discovery, while the emergence of discovery services helps locate agents and tools more efficiently, it also introduces potential spoofing attack vectors that we must address. As we move forward, consider this important action item. Conduct an inventory of all protocols currently in use and ensure you have a solid version control and patching plan in place. Next, we'll explore the core security concerns outlined in the OWASP threat model. Building on our discussion about protocols and the emerging network for agents, let's now explore the critical threats outlined in the OWASP threat model. Understanding these threats is essential for safeguarding our systems. First, we have memory poisoning, which involves the injection of false content into an agent's memory or retrieval stores. This can lead to serious misinterpretations of data. Next, we encounter tool misuse and agent hijacking. Here, deceptive prompts can mislead agents into invoking incorrect tools, potentially causing significant disruptions. Privilege compromise is another concern, often stemming from misconfigured permissions and token leaks, which can expose our systems to unauthorized access. Cascading hallucinations can occur when false information propagates through agent networks, making it increasingly difficult to discern truth from fiction. And there's identity spoofing, where attackers impersonate legitimate agents, and human manipulation, where agents are used to deceive users. Next, we'll take a closer look at memory poisoning, what is and why it matters. As we transition from our exploration of key security concerns, let's take a closer look at a particularly insidious threat, memory poisoning. Memory poisoning occurs when attackers inject false or misleading content into an agent's memory or retrieval systems. This manipulation can fundamentally alter future decision-making processes, leading to potentially dangerous outcomes. For example, imagine a poisoned README file or a compromised shared document within a retrieval corpus. This can result in reports that contain seemingly legitimate but actually manipulated information. Serious risk for any organization relying on accurate data. To defend against this threat, there are several key strategies we can implement. These include using version ingestion pipelines, establishing signed provenance tracking, and conducting automated poison detection tests. Additionally, incorporating manual review processes for high-sensitivity sources can further bolster our defenses. Now, let's look ahead to the next topic, where we'll discuss the risks associated with tool misuse and how deceptive prompts can lead to goal manipulation. As we shift our focus from memory poisoning, let's delve into another critical aspect, tool misuse and goal manipulation. This attack vector is particularly insidious as it exploits deceptive prompts or poison context to mislead agents into executing commands incorrectly. For instance, they might unintentionally invoke actions like transfer, delete, or shell commands without fully understanding the implications. To counter these risks, it's crucial to implement robust controls. This includes creating function call allow lists and establishing virtual capability tokens that grant fine-grained permissions. Additionally, setting invocation rate limits can help mitigate abuse. Human oversight plays a vital role here as well, requiring confirmation for high-impact calls and employing dual control for financial operations ensure an extra layer of security. Before we move on, consider incorporating a quick configuration checklist that includes per agent tool access controls, approval gates for different environments, and dual control measures for financial transactions. Next, we'll explore the challenges posed by privilege compromise and supply chain risks, including issues stemming from misconfigured service counts. Stay tuned. Building on our previous discussion about tool misuse and deceptive prompts, let's now dive into another critical area, privilege compromise and supply chain risks. Misconfigured service counts or token leaks can inadvertently grant agents more permissions than they should have. This is particularly concerning when you consider that coding agents often connect to repositories, introducing substantial risks into our supply chain. To mitigate these dangers, it's essential to implement principles of least privilege, ensuring that agents only have the access they absolutely need. Additionally, utilizing ephemeral tokens with limited lifespans can significantly reduce risk, creating dedicated service counts for each agent and employing secret vaulting practices, where sensitive keys are not embedded in memory or logs, are also vital steps we should take. In our upcoming demonstration, we'll showcase short script that rotates ephemeral credentials and binds them to an agent role, illustrating these concepts in action. Let's explore how we can strengthen our defenses against these vulnerabilities. As we move forward from our discussion on privilege compromise and supply chain risks, it's crucial to address the issue of cascading hallucinations. This phenomenon begins with an initial hallucination agent that generates misleading information, which may seem plausible but is ultimately false. Once this misinformation is introduced, it can quickly propagate through networks of agents where it's often accepted as truth. Unfortunately, downstream agents can treat these hallucinations as verified facts, leading to a dangerous cycle of misinformation. This amplification can embed false narratives into decision-making processes, significantly impacting outcomes. To combat this, we can implement several key defenses. Techniques such as provenance propagation, setting confidence thresholds, and employing verification steps with deterministic tools, like checksums and ABs, are vital. Additionally, human review on critical paths becomes essential in ensuring accuracy and maintaining integrity. Next, we'll explore unexpected remote code execution and code execution attacks, focusing on the attack surfaces within agent environments. As we transition from our discussion on defenses against cascading hallucinations, let's delve into critical area of concern: unexpected code execution and remote code execution attacks. In environments where generated code is executed, such as sandbox Python or JavaScript, there is significant risk of code injection attacks breaching these protective barriers. To mitigate these risks, adopting certain critical controls is essential. For instance, ensuring minimal execution privileges and employing hardened sandboxing environments can greatly enhance security. Additionally, conducting both static and dynamic analysis of the generated code is vital to identify potential vulnerabilities. A practical tip to consider is running the generated code in containers with restricted capabilities, such as disabling network access and applying seccomp profiles, especially during testing. Now let's shift our focus to another crucial topic: the importance of identity, repudiation, and observability in tracking actions and ensuring accountability. As we shift our focus from unexpected RC and code execution attacks, let's delve into a critical issue: the challenges of identity, repudiation, and observability in agent environments. In many systems, actions taken by agents can't be traced back to specific identity. This creates significant problem as attackers may impersonate legitimate agents, complicating forensic investigations. Without clear accountability, it becomes difficult to determine who did what, leaving systems vulnerable to exploitation. To combat this, we can implement several key mitigations. By using cryptographic identities for agents, along with signed reasoning traces and immutable timestamp logs, we enhance our ability to track actions effectively. Additionally, exporting this data to security information and event management systems with established correlation rules strengthens our observability. Now, let's explore how these agents communicate and the potential threats posed by communication poisoning. Building on our previous discussion about identity, repudiation, and observability, let's delve into a significant challenge in multi-agent systems: communication poisoning. In environments where agents communicate, there is risk that poison data can spread throughout the network. This contamination can severely distort decision-making processes, leading to erroneous outcomes. Furthermore, we must be aware of adversarial coordination, where multiple agents work together to circumvent individual security controls. To combat these threats, implementing robust mitigations is essential. This includes establishing secure authentication protocols between agents, ensuring the integrity of each message, and enforcing clear delegation boundaries. Additionally, maintaining trust registries among inter-agent communications can bolster security. A critical governance requirement is to mandate attestation before accepting decisions from any external agent, ensuring accountability and accuracy. Next, we'll explore strategies for defense in depth, focusing on the three critical pillars of security. As we transition from understanding the risks posed by communication poisoning, let's now explore a robust strategy to mitigate these threats through defense in-depth approach. This strategy is built on three essential pillars. First, we focus on prevention. Implementing least privilege access controls ensures that individuals and systems only have the minimum access necessary to perform their tasks. Utilizing tool lists and deny lists can further safeguard against unauthorized tools. By sandboxing tool execution and applying rigorous input filtering and validation, we create a strong barrier against potential threats. Next, we move to detection. Real-time observability and monitoring can reveal anomalies in tool usage patterns and memory changes, while behavioral analysis helps us identify unusual activities. Finally, we must have effective control and response mechanisms in place. Incorporating human-in-the-loop checkpoints, emergency kill switches, and rollback capabilities ensures we can respond swiftly to any incidents. Take a moment to map your organization's existing controls to these pillars for each agent class as we prepare to dive into specific technical controls next. As we transition from our discussion on the three essential pillars of defense in depth, let's delve into the practical aspects of securing our systems through specific technical controls. At the heart of our strategy is the implementation of role-based access control, or RBAC, for agents and service counts. This means that each role is tailored with the least privilege principle in mind, ensuring that agents have only the permissions necessary for their specific functions. Additionally, we utilize secrets vaulting and ephemeral tokens, which enhance security by requiring agents to request scoped secrets at the moment of need rather than relying on long-lived credentials. This practice significantly reduces the risk of unauthorized access. We also implement tool allow and deny lists, which prevent unauthorized tool usage alongside memory hygiene practices like version storage and automated testing. To maintain accountability, we generate signed reasoning traces, providing immutable logs that serve as valuable audit trails. Our next segment will explore the critical area of observability and benchmarking, focusing on what to log for effective monitoring and analysis. And building on our discussion about concrete technical controls, let's dive into the importance of observability and benchmarking. To ensure our agents operate effectively and securely, we must capture essential data points. This includes logging raw prompts and model responses, as well as monitoring memory writes and reads. Additionally, keeping track of tool invocations with their parameters, model versions, and seed values is crucial. Timestamps and cryptographic signatures help us establish a clear chain of accountability. To enhance our security posture, we can integrate with SIEM and SOAR platforms, allowing us to create agent-specific alerting rules. For example, we might want to trigger alerts for unusual patterns, such as unexpected spikes in tool calls or unexplained memory mutations. Next, we'll explore how to implement robust testing and red teaming strategy, focusing on continuous integration. This will help us proactively identify vulnerabilities and strengthen our defenses. Building on our discussion about observability and benchmarking, we now turn our attention to an essential aspect of ensuring the resilience of our systems, testing, and red teaming strategies. First, integrating adversarial tests into our continuous integration processes is crucial. This includes employing prompt injection suites, RAG poisoning tests, and tool sabotage scenarios to challenge our models proactively. Next, it's vital to understand that static pre-deployment tests alone won't suffice. Continuous red teaming is necessary for adaptive agents that learn and evolve, ensuring we stay ahead of potential threats. To manage this effort effectively, we adopt a structured approach. A weekly test matrix helps us map severity, likelihood, and remediation ownership, ensuring systematic coverage and preparedness against vulnerabilities. Now let's explore the next essential component, governance and compliance, particularly focusing on live compliance documentation and model versioning. As we transition from our discussion on integrating adversarial tests into continuous integration, let's now focus on the evolution of governance and compliance in our AI strategies. In today's fast-paced environment, static annual audits are becoming a thing of the past. We're moving towards a dynamic model that emphasizes live compliance documentation. This includes model versioning and unmanned justification reports, all supported by real-time dashboards. This shift is crucial as we prepare for upcoming regulations like the EAI Act and the G guidelines, which mandate detailed logging, red team reports, and kill switch protocols for high-risk deployments. To ensure we navigate these changes effectively, it's essential to establish an AI governance committee. This committee should include representatives from engineering, security, legal, and risk management, allowing us to map AI agents to appropriate legal risk tiers. To assist you in this endeavor, we've provided a one-page template for an AI governance charter in your materials. Next, we will delve into procurement and vendor evaluation, focusing on essential questions to ask vendors regarding their security controls. As we transition from our discussion on governance and compliance, let's turn our attention to a crucial aspect of the procurement process, evaluating vendors. When assessing potential partners, it's vital to ask essential questions regarding their security controls. We'll want to delve into their per-agent role-based access control capabilities, as well as their procedures for handling sensitive information. Understanding their patch management and versioning policies is equally important, ensuring they have robust protocols in place for addressing vulnerabilities. Additionally, we should seek insights into their security testing practices, including benchmarks, red team reports, and artifact signing procedures, which are all critical for maintaining data integrity and security. To date in this evaluation, we've included a procurement scorecard template in the training materials, which will streamline your assessment process. Next, we'll explore how to create an operational playbook for the first 90 days, focusing on effective discovery and inventory management. Building on our previous discussion about procurement and vendor evaluation, let's dive into the operational playbook for the first 90 days. In the initial weeks, we focus on discovery by inventorying agents, connectors, and protocols. This step is crucial for creating AI software bill of materials, or AISBOM, which gives us a clear understanding of our operational landscape. As we move into weeks 3 and 4, we'll apply least privilege principles to agent service counts. This is essential for minimizing risk and ensuring that only necessary access is granted. Weeks 5 and 6 are dedicated to enabling immutable and signed logging with a focus on exporting this data to our security information and event management system. In the following weeks, we'll establish clear policies and conduct regular adversarial testing to ensure our defenses are robust. Finally, we'll prepare emergency response strategies, including kill switch and rollback procedures, ensuring we're ready for any unexpected events. Next, we'll explore hands-on workshop scenario focused on the HR onboarding agent and its crucial access requirements. Now that we've explored the operational playbook for the first 90 days, let's dive into a practical scenario, the HR onboarding agent. This hands-on workshop will provide a unique opportunity to apply what we've learned about data flow and security. You'll start by designing data flow diagram to visualize how information moves through the HR onboarding process. Identifying RAG sources will be crucial here. Next, we'll shift our focus to threat analysis. Using the OWASP threat taxonomy, you'll list the top 5 potential threats that could impact our onboarding system. Finally, you'll design technical and governance controls to mitigate those threats. 3 technical and 2 governance controls will be your targets. At the end of the workshop, your team will present a 5-minute summary along with a remediation checklist. This exercise is vital for ensuring that our onboarding process is secure and efficient. Next, we'll discuss how to measure our progress and key performance indicators. As we transition from our hands-on workshop scenario, let's delve into the important metrics that will help us gauge the effectiveness of our HR onboarding agent. First, we have the mean time to response, ATR, which should be under 15 minutes when it comes to detecting and addressing any anomalous behavior from our agents. This quick response is crucial for maintaining security and trust in our systems. Next is the privilege compliance metric, aiming for at least 95% of agents to have least privilege access controls properly enforced. This ensures that each agent only has access to the information necessary for their role, significantly reducing risk. We also track the number of unauthorized tool calls that are successfully blocked by our security measures, aiming for a zero-tolerance policy on prevented attacks. To enhance our anomaly detection, it's vital to instrument dashboards that reflect baseline expected behavior patterns for each agent. This will empower us to identify irregularities effectively. Looking ahead, we'll explore emerging threats and strategic considerations that may impact our approach moving forward. As we shift our focus from KPIs and progress measurement, it's essential to consider the future landscape of cybersecurity. Emerging threats are evolving rapidly, with adversarial coordination and behavioral reverse engineering creating new attack vectors that organizations must prepare for. Additionally, self-amplifying agents pose significant challenges, amplifying the need for vigilance. We also see a shift in regulatory landscapes with stricter cross-border regulations and new standards like ISAIC and NIST. These will require organizations to provide live evidence and enhance their explainability efforts. To effectively combat these emerging threats, it's crucial to allocate resources appropriately. This means securing budgets for continuous red team exercises and investing in advanced observability tools. By doing so, we can stay ahead of these evolving threats and protect our systems effectively. Next, we'll explore valuable resources and further reading to deepen your understanding of these critical topics. As we transition from our discussion on future trends and emerging threats, it's crucial to equip ourselves with the right resources to navigate these challenges effectively. This slide highlights key primary sources that can enhance our understanding of Agentic AI and its security landscape. First, we have the OWASP State of Agentic AI Full Report, which provides an in-depth exploration of potential vulnerabilities and mitigations. The Agentic initiative offers additional valuable insights with resources like the Threats and Mitigations Guide and the Securing Agentic Applications white paper. For practical applications, consider exploring the vulnerable agentic code samples and security benchmarks from platforms such as Agent Dojo and Agent SafeFi Bench. These tools are essential for testing and securing agentic applications. Remember, all resources, templates, and checklists from this training are available in the accompanying materials package, ensuring you have everything you need to implement best practices moving forward. Stay tuned as we delve into actionable strategies in the next section.